Hi, class. I'm excited to be starting chapter 16 with you. We're going to be going over probabilities, odds, and expectations. So I'm so excited to go over this section with you because probabilities are all around us. What is the probability that it will rain today? Oh, there's a 60% chance. Probability means a likelihood of something happening. So what's my probability of getting a divorce? Or what's my probability of winning the lottery? So it's the likelihood. Probability is the likelihood that something will happen. And I'm so excited to go over this chapter with you because probabilities exist. Now that they're not exact and they're not perfect, it's just a prediction, right? And some are more educated than others, but they help us make wise choices. And the better you understand probability, the more the value you will rest or will choose not to rest in probabilities that are stated to you. So I'm excited to go over this section. So the first thing that we have to go over is just some definitions. In 16.1, we're going to go over the definition of a sample space and also events. So a sample space is a precise description of all of the total possible outcomes in a certain situation. And an event is a subset of the sample space. The event is usually what we wish to occur or what we're hoping occurs. So like, here's an example. And the sample space is thought of as all the total possible things that could happen, while the event is what I would like to happen, usually, okay? Or what we're hoping will happen. So let's just think about this way. If the 49ers play the 49ers football team, plays the Cowboys football team, and let's say just for a second here that a tie is possible. I'm not sure. I'm not even like a football fan that much, so I don't even know if like actually during the games if a tie is actually possible. But we're going to say for this example that a tie is possible. So if they play each other, write out the sample space, means write out all the total possible outcomes. So they could win, right? I'm going to put win. They could lose. And in this situation, for this example, I'm going to say they could tie. Okay, those are the three total possible outcomes of two people playing a game. It's all the possible things that could result in the end, right? Okay, so then let's go on to the next one. We're just going to go over and we're going to write out the sample space for different events using a set notation. Write the sample space of tossing a coin 2 times. So say we've written a coin, I have a picture of a coin right here. And we're going to toss the coin a first time and then also a second time. So let's just focus on if I toss a coin a first time, and usually when we're tossing a coin, it's in reference to whether it lands on a heads or a tails. And often, speaking it back into football games, or often right at the beginning of a game to decide who gets to be offense, defense first, or whatnot, they usually toss a coin. And depending on how the coin lands, then if it lands on if it lands on heads, the face of the coin that has a head on it, and you called heads, then you're the one who gets to choose what they want to do, offense or defense or whatever, right? First. And then if it lands on the opposite side that you did not call, then the other person gets to get their way, right? So that's how usually we use a coin. So if I toss it the first time, and what we're interested in on the coin is how the coin lands, either heads or tails. So H is for heads here and T is for tails. So the first coin, I'm just thinking about the first coin. The first coin could land on a heads, right? So I'm going to put an H in parentheses. And I like to use these little curly brackets to list out everything in sample space. So technically I should have put in curly brackets around the win, loss, and tie. I should say the win, lose, and tie, but whatever. Okay, so the first coin could land on heads if we're tossing not one coin, but 2 coins. I guess let me just back up really quickly here. If I'm just tossing one coin, then the sample space would be, it could either land on heads or it could land on tails. If that's what we're observing is what it lands on, either heads or tails. That is the sample space if I flip one coin. It could land on heads or it could land on tails, right? That's the total possible out. That's all the total possible things that could result, right? Now let's get a more complicated question is what if we toss the coin 2 times? So the first time the coin could land, the first time we throw it, it could land on heads. And the second time, it could also land on heads. So that is one of the outcomes that could happen when we toss a coin twice, right? And the first H is for the first toss, the outcome of the first toss, and the second H is the outcome of the second toss. Means that, okay, then I could get a heads on my first toss and I can get a tails on my second toss, right? Or I could have gotten a tails on my first toss and a head on my second toss. That is another way that it could have happened, right? Or it could have gotten a tails on the first toss and a tails on the second toss, right? So those are all of the total possible things that could happen, right? I mean, because it makes sense. Each toss could be either tails or heads, and each of the second tosses could have been tails or heads. So it makes sense. There's 4 total possible things that could happen. Okay, if we kind of change our observation, what we're focused on, maybe we're only focused on heads because we always vote heads. So if we were playing some kind of game where like we're tossing up coins and then every time it hits a head, we get $1 or something, and we're just focused on just the heads only. Let's redo the sample space. So okay, so this is per part B. If the observation is just your number of heads, the observation is the number of times the coin comes up heads. So we're still tossing it 2 times because it says you toss at the very beginning of this problem, it said you toss a coin 2 times. We're still tossing it 2 times, but we're just recording the number of heads that it landed on. So we could just, it's kind of the same as above. It's the same question as above. It's talking about how the coin lands, but instead of saying, and it's the same possible 4 outcomes. It could land on heads, tails, heads, tails, tails. But instead of writing it that way, we're writing it, okay, instead of writing HT, we're going to write how many heads occurred in each of these, right? So look at this first outcome. I could have 2 heads. So that's a possibility. And look at the second outcome. I could have 1 heads, right? And the third outcome, but that's just another time that there was 1 heads. But so we already know that an outcome is that we can have 1 head. So I'm not going to list that one twice. But and then the last one has tails, so it's 0 heads. So that all the total possible outcomes, if all I do is record down, if I flip a coin twice and I record the number of heads that I got by flipping a coin twice, the total possible outcomes are I could have gotten no heads, that would be 0 heads, so I put as 0. I could have gotten one head, or I could have gotten 2 heads. So those are all of the total possible outcomes of of the number of all the different numbers of heads that we could possibly have rolled. Okay. Now here's the next one. A board of directors at a company has 4 members: Allie, Brad, Kara, and Dan. So I can just use A for Allie, B for Brad, C for Kara, and D for Dan. That's okay. Then they say, write out the sample space of the following. A chairman and a treasurer are elected. So how many different ways, if there's 4 people, could a chairman be elected and a treasurer be elected? So the first way is that Allie and Brad, and I'm going to say the first person is the chairperson and the second person here is the treasurer. So it could have gone that way. And it is a little bit more difficult to write out than, I don't know if I'm going to use these. I'll just say, I'm going to use regular parentheses around each possible outcome. So we could have the possible outcome that Allie is the chairperson and Brad is the treasurer. The other possible outcome is that Brad could be the chairperson and Kara could be the treasurer, right? It's a possible outcome. Right? Or it could be Kara, who is the chairperson, and Dan, that is the that is the treasurer. Or, but that's not it. That's not all of the pairs of 2 that we could possibly have here. And I think just for a matter of space, I'm going to start writing A here instead of Allie and B instead of Brad. That's okay. And there's something true in mathematics. You want to have plenty of space to write out what you want to write out. So I might even go to another page and just just so that we have plenty of space, or maybe I'll just like, for the time being, I'm going to erase this one. And we'll just list them on this page as best as possible. But it's important in math to have plenty of space to write, because when we don't, then we start making mistakes. And it's not because we're, like, it's not because we don't know the math. It's just because if we get sloppy and we write things small and then we don't understand what we're writing and stuff like that. So Allie and Brad, Brad and Kara, Kara and Dan. But we could also have Dan and Allie. I don't think I put that one down yet. And I could have, so I said Dan and Allie. I already did Allie and Brad, but I could do Allie. So I've already done everybody that's like kind of, if you will, they're like next to each other. So now I'm going to do who is not next to Allie. So Allie could be with Kara, right? And also Allie could have been with Dan. Wait, Dan, oh, Allie's already with Dan. Allie's already with Brad. and Allie's now with Kara. So I think we have all of the pairs that have Allie in the group. Now, I just realized there's probably a better way to be writing this out. And this is something important when you're in this section. And I'm kind of glad I kind of did it the way I did, and now I'm going to do it differently. It's important to kind of keep and to stay as organized as you are, because you can when you're counting out all the different possible outcomes. Sometimes these lists are long and it's easy to get confused if you don't have like a organized way to write it all out. And I don't like the way I'm writing out, so I'm going to restart it. And I'm going to just go with Allie and everybody with Allie. Okay, so I can go with Allie. And I can go Allie with Brad. I can go Allie with Kara. I can go Allie with Dan. Then I can go Brad. So I listed all the groups with Allie and Dan in them. Okay, now we can go with Brad and Kara. We've already listed, actually, we can go Brad. I'm going to go ahead and write Brad and Allie, because that is a different group. So this is kind of what I'm thinking. I'm thinking Allie could be, one possible outcome is Allie is a chairperson, and the other person is all the other three. The other outcome is that Brad could be the chairperson, and the other three could be the treasurer. So, okay, then the next one is Kara. All right, and then the next one is Dan. So I can consider Dan is the chairman and everybody else are the different. Usually I'm trying to go in alphabetical order with the second person that I list. Just stay a little bit organized. Okay. So sometimes it's easier to kind of, when you're doing a problem like this, to kind of, they say, pick a chairperson and a treasurer. So it's better to kind of pick a chairperson first, to say, and then let everybody else be the treasurer, and then consider, okay, what if the second person is the chairman, then everybody else is the treasurer, and so on. So that's a pretty good way of kind of thinking about the first. If I kind of think about the first thing happening and then not set in stone, and then letting everybody else vary. And so that's kind of a good way to write everything else in an organized manner in this type of problem. So here are all the different possible things that could happen. Allie could be the treasurer. I'm sorry, Allie could be the chairman, Brad could be the treasurer, Allie could be the chairman, Kara could be the treasurer, Allie could be the chairman, Dan could be the treasurer, and so on. Brad, in this next line, it says Brad is the chairman, Allie's the treasurer. Brad is the chairman, Kara is the treasurer, Brad is the chairman, Dan's the treasurer, and so on. We've listed out all of the total possible ways that a chairman and a treasurer could be elected. Okay, so that's that problem for part A. And we would also notice, I just noticed here that there's 12 different possibilities. So there's, you know, every pair like that I put in parentheses is is one possible outcome. So if I wanted to, it could be good with my notation and put them all in the big curly brackets that's my sample space. All right, for the next question, they say 2 directors are selected for a search committee to hire a new CEO. So this problem is very similar to the previous problem. 2 directors are selected. The difference here, if 2 directors are selected, that means when I selected, look at Allie and Brad, and then the next one here is Brad and Allie. That's the same scenario. If the 2 people are the same, they're just directors. And like the first one isn't a chairman and the second one being a treasurer. So with the second problem, we want to list what we call every combination of 2 people, which means just every group of the different two different people. But we don't want the orders we don't want to count the different orders of those people. So like I said, in the first problem, because the first person is a chairman and the second person is a treasurer, and that's a different situation than the first person, the second person being a chairman and the first person being a treasurer. Those are 2 different situations. So that's why we had to list Allie first, then Brad, then Allie. But with this situation where you ask, there's 2 directors are selected from the committee. Now we don't need to list the different orders. We just need to list the different groups of people, all the different groups of 2 that we could make. So what I would do to be the answer to part B, I would just use the list I created for part A. And then I would cross out the opposite order. So like I already have Allie and Brad, they're already, they could be 2 directors, but I don't need to list them a second time because I erase Brad, Allie. So like I have Allie, Kara, so I find out where Kara, Allie is, and I erase that because we don't need that listed the opposite order, like I said, to answer for number 2. So I would go back to, so then I would look at Allie and Dan. It's listed Dan and Allie down here. I'd erase that, right? So then I'd go through, okay, Brad and Kara. Do I have Kara and Brad somewhere? Yeah, I have it right here. All right, so Brad and Dan, I'm just going down the list, making sure I don't have those 2 people already listed, but just in a different order, right? If I do, I cross it out. So Brad and Dan, yeah, Brad and Dan is listed down here, so I erase that. And then Kara and Dan, well, yeah, I already have it down here. So all the ones that I did not cross the line through, they are all the possible outcomes for picking 2 directors. So there are 6, I believe. So here's one possible outcome, the second, third, fourth, fifth, sixth. So there are 6 different ways that you could choose 2 directors. So in general, like we say for a problem like part A, we would say order matters. So when they say order matters, it means we want to list both Allie, or, Allie first, then Brad, and we're going to list Brad and Allie as on our list as well when we're listing out everything in sample space. But if they say order does not matter, then we usually we don't, we just list it like part B here, where just we just list the groups of people, and we don't list the different orders that they're in as well. Okay, all right. Let's go on to the next one. A die is a little cube that has 6 sides. So it looks like this. And if I look at each little face on the cube, it would look like the one side would look like a 1 with a dot. 1 dot means 1, and 2 dots means 2, of course. And so here's the different faces, what they look like. I wanted you to kind of really, just in case you've never played like a game before that involves a dice, I wanted you to see what it looks like. Okay, so here's what it looks like when someone rolls a die. And a die or dice means 2 of them. And this is dice are used in many games. So some of them are, for whatever reason, maybe you've heard of the game Bunko or I think Yahtzee, but there's lots of just games that use dice. So let me just show you what a roll of a dice looks like. So the idea is that you roll the dice and it's a matter of just chance. No one knows what it's going to land on. And you're hoping that it lands on the numbers that you want it to land on. All right, so you saw what a die looks like, and a pair of them is called dice. But if I roll just a single die, and the likelihood that it lands on any of the numbers is exactly the same. So I'm just as likely for the die to land on a 1 as it is a 6 or any of the sides. But if I roll a die, write out the event that the die lands on a odd number. So what are the possible odd numbers that it could land on? So we see the different faces over here. So look, it could land on a 1. That's an odd number. This is the sample space. So it's all the possible odd numbers that it could land on. So it could land on a 1, it could land on a 3, or it could land on a 5. That is a sample space of, and we call this event, which I guess sample space, when I roll a dice, all the total possible outcomes are the numbers 1 through 6, right? So here's your sample space of rolling a dice. It's 1, 2, 3, because it could land in any of the faces. So then the event, which is a smaller thing than the entire sample space, the event that it rolls a 5 contains the numbers 1, 3, and 5, because those are the only numbers that have odd numbers on the face of the dice. Okay, so notice how an event is a small group of the original sample space. So we have the numbers 1 through 6, and a small group, or just part of the sample space, is this event, which we see here. Okay, that's what a subset is. A subset is part of a larger group. So, all right, going on to the next question. A pair of honest dice are rolled and the points are added. Here is a sample space for rolling a pair of honest dice. So whenever we think of a pair of dice, we always kind of think about one of them being white and one of them being red, even though that kind of just helps us to figure out all the total possible outcomes, because you do have 2 dice. So one of them could be 5 and the other one could be like, so like, for example, one of them could land on a 5 and the second one could land on a 1. So that's a possible outcome. But also, the first dice could have landed on a 1 and the second dice could have landed on a 5. So that's another possible outcome. And we have to make sure to list both of those, even though they seem so similar and they seem like, isn't that the same thing? But you have 2 dice. So we have to kind of in our mind think, even though if they are both white dice, we have to think about one being red and one being white, or one being the first die and one being the second die. And we have to consider the situation where the first one is 5 and the second one is 1, and that's a different situation than the first one being a 1 and the second one being a 5. Okay. So this is what could possibly happen when you roll 2 dice. Both of them could end up being a 1, land on a 1, that's a possibility. The first one could land on a 1, the second one could land on a 2. The first one could land on a 1 and the second one land on a 3, and so on. Okay, so this is all the possible. So each pair of little dice here is another possible different outcome. So if we count them, there's like 1, 2, 3, 4, 5, 6, and there's 1, 2, 3, 4, 5, 6. So there's 36 little there's possible outcomes of rolling 2 dice. Now they say, write out the event that the sum is 5. So how many different ways can we get the sum being 5? So I could see, well, we have to think about all the numbers first that add to 5. So, but that are between 1 and 6, of course, because we can't get, the dice is going to roll a number between 1 and 6. So to get 5, I could do 1 plus 4. Okay, so I have to circle all the ways I could get 1 plus 4. So I'm going to use a brighter color here. So 1 and 4 is right here. That's right here. And then there's also 1 over here. There's 2 ways to get a 1 and a 4. And then I could list both of those as the outcome of my event. So I could have I'll just say 1, 4. That is an outcome of the event, the sum is 5, or 4, 1. And I probably should have just redrawn these pictures down here, but that's okay. I'll just I'm representing this picture of the little dice being 4 and the dice being 1. I'm just rewriting it as 4, 1, because I don't want to write the little cubes and whatnot. Okay. And then next we need to list all the ones. I'm thinking of, how do we get 5? We could do 2 plus 3, right? So I have to circle all of those. How many 2 plus 3s how many ways could it land on a 2, 3? So here's 2, 3 right here. But then the first die could be a 3 and the second die could be a 2. So there's it right here. So we could think about that as 2, 3 or 3, 2. Are there any other ways that we could land on these dice that add to 5? So first of all, we see that one dice is 5, but it's impossible for the die to land on 0 because it's between all the numbers on the side of the dice are between 1 and 6, right? So it can't be 0. So I can't, if the die lands on 5, it's not going to be a sum of 5. So we can only consider numbers that are smaller than 5 to add to 5. And we already considered all the numbers. All the numbers smaller than 5 are 1, 4, 2, and 3. So I think we found all the different ways that we could possibly get 5. So this is what the event looks like. Like I said, this is this total sample space of rolling 2 dice. And this is Well, even better is if you just look at the 4 that I circled, that is the event that, or the event written out that they add the sum is 5. Okay. And then, okay, so let's move on to the next one. But I tried to write it some in a different way over here. Okay. The next one says, write out the event that the sum is less than or equal to 3. So I'm going to circle all the, so I think about less than or equal to 3. I think about 1 plus 1. I'm just trying to brainstorm right now. And then I'm going to actually circle the answers on the picture. But okay, so 1 plus 1, that's 1. Okay. So I'm going to write that response as 1 comma 1. That's a possible outcome. And then I could get 1 and 2, because that would be 3 as well. So that'd be here, because it could be equal to 3, less than or equal to 3, right? So that's 1, 2, and that's one way to do it, or 2, 1. That's what I'm writing for those two. And if anything is, I try to kind of look, or if I add anything to like 1, the next thing to do would be adding 1 plus 3, but that would be bigger than 3. So that these are all the things that could happen that would make the sum be 3 or less. There's only 3 ways to do that out of all the total possible landings of the dice. When all right, write out the event that both numbers will come up as odd numbers. So we let's circle all the numbers that both numbers come out as odd numbers. So we just said go to the sample space and we circle all the times they both are odd. So 1 and 1. So I'll list that as one of our answers. Then 1 and 3. List that as one of our total answers. And actually 3 and 1, right? I'm gonna go ahead and just write that right away as well, because here's 3 and 1. Then, okay, 2 and 2 is not gonna work. So maybe 1, I'm just going down this list. It's 1 and 5 is another one. I'm going to list all the ones that contain 1 in them first to keep it a little bit organized. Then I'll do the opposite, 5 and 1. Then that's all that have a 1 contained in them, because 1 and 2, 1 and 4, and 1 and 6 don't both have odd numbers. Then we would just think of numbers higher that do not contain 1. So maybe 3, I looked down the list of 3, so 3 and 3 is one of them. And then I looked down the list of 3s again, 3 and 5 is one of them. And then I'm going to list the backwards of that, 5 and 3. Now, all the 4s are not going to be in it, but I'll go to the 5s. And the 5 and 1, we already listed that though. So then 5 and 3, we already listed that. And then 5 and 5 is 1, so I'll list that, 5 and 5. Five and 6 is not one, and none of the ones doing 6 are listed there. So I could have just circled every single one that was, I could have just started at the top here and go from right to left down every single row. Just if I saw 2 that were both odd, I could just circle it. So that's another way of doing this problem. So let me just make sure I have all of them listed here. This makes sense because the first row is 1s, which the first, third, and fifth are going to be in it. And the second row is not going to have any because it has an even number. But the third row is going to have some, so that's the first, third, and fifth. So it's going to be in it. And then the fourth row, fourth row has 4, so that's not going to be in it. But the fifth row has 5, so it's the first, third, and fifth that are going to be in it. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, it looks like we got everything in the event. All the different ways that I could roll 2 odd numbers, I believe I circled them and listed them down here. So that looks good. All right. Next. And I apologize, this first part, we're showing you, we're introducing you to what a dice is, if just in case you didn't know what it was and you never played with it. I don't want to assume, make assumptions. And the same thing with the deck of cards. So the lecture's a little bit longer, but it's going to help us understand the problems that we come into later on. So that's why. So just be patient with me. Okay, section 16, we're still 16.1. And just so that you know, just in case you've never played cards before, which is completely okay, just depending on your culture or your family, like what you enjoy doing, you may or may not have played cards, but that's okay. But it's important for you to understand what a deck of cards is, a standard deck of cards. So I'll explain it to you. An ordinary deck of playing cards, so it looks like what we see below here. Maybe I can even try to get it as big as possible. There are 4 suits. Oh, wait. An ordinary deck has 52 cards, no joker included. Usually we don't enjoy dark. They do have jokers. Usually they come with jokers, but most games don't use jokers. So we just usually, when we're talking about a standard deck of cards, we're usually talking about just the 52 cards without the jokers. There are 4 suits, clubs, so that it looks like the little 4-leaf clover that's in black here. Diamonds, so it looks like, you know what the diamond shape is. And then hearts. And then the last one is spades, which looks like, it looks like a spearhead. So there's 4 different suits. And then each of those suits having 13 cards numbered ace through king. So let's see that. So this is an ace. It looks like an A, but sometimes in some games it's thought of as a 1, as a number 1, but it has an A for ace. And other games, sometimes they'll think of it, most of the games that I've ever played, they think of the ace as the highest card, which is the 14th card, because if they start with 2, and then they go up to, there's 13 cards, and they just keep counting up from 2, then we think of it as having a value of 14 normally. An ace usually has a value of 14, but depending on the game you're playing. But anyways, so this is ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a jack, and I don't know why they do this, but instead of having an 11, they put a jack, but the jack has the same value in most games as an 11. And then a queen instead of is like the value of a 12, if you will, like for most games, but not all games. And then king has a value of 13, and like I said, ace is usually the highest value card, which is a 14. But anyways, and then we have all that same setup in every single different suit. So we had that in the spades, ace through king, and then ace through king, that exact same setup, but in hearts. And then in that exact same setup in diamonds, and the exact same setup in clubs. So that is what a standard deck of cards looks like. They usually call these cards that have the jack, king, and queen, they usually call those the face cards, because you can see their little, let's see, you can see their little faces on them, right? So that is, they usually call those the face cards. Yeah. Okay. So they just explain that out to you. And then they say, okay, if they usually use an H for hearts, C for clubs, D for diamonds, and S for spades. And then 2D denotes 2 diamonds. So that's some of the notation that we'll be using. So with this in mind, and this is what a deck of cards kind of looks like when you have them not laid out, like they're not usually laid out like this, like all, right? They usually are in a stack and they're all mixed. And when we pick a card out, we don't know, it's going to be one of these, but we don't know which one, right? So that's what the way it usually is. And I don't know if you've ever heard card tricks, but some magicians will ask you to pick a card. They'll mix up the cards really, really good. They ask you to pick a card, and then you see the card, and then they magically tell you what card you have, and you don't know why or how they did it. But that's usually just a fun magic trick if you've ever been with been to a magician's show. But anyways, they ask us here, using set notation, which is those little curly brackets, write out the event described by the following statements. Draw a jack. So I could draw what are the different ways that I could draw a jack? Mind you, this is the sample space of if I draw a card, these are all the different possible outcomes, are all the different cards that are in the deck. So if I draw a jack, there's 4 different ways that I could do it. I could draw a jack, I'll use the J for the jack, a jack of spades, so JS, or jack of hearts, I'm just going down, jack of diamonds, or I could get a jack of clubs. So there's 4 different ways. If I really was playing a card game, I hope I get a jack. I hope I get a jack. You can see it. There's 4 different jacks there. A jack of clubs, a jack of diamonds, a jack of hearts, and a jack of spades. Okay. So that's the 4 different ways, the 4 different things that are in this event. Then the next event is draw a club. Well, there is, when we look at the clubs, I could get an ace of clubs, a 2 of clubs, 3 of clubs, 4 of clubs, 5 of clubs, 6 clubs, 7 clubs, 8 clubs, 9 clubs, all the way to king, right? Ace to king of clubs. So that's, I'm going to list, and I'll just put A, and I'll just put AC, and that is short for ace of clubs. 1 or 2, there's no 1 in a deck of cards, well, unless you're counting ace as the 1. But it's a 2 of clubs, or a 3 of clubs, a 4 of clubs, and of course, I remember there's not an 11. They call the 11 a jack. So jack of clubs, queen of clubs, and king of clubs. And that is the if I wanted to draw a club, I would want to pick one of those. Then it says draw a face card. A face card is a jack, queen, or king, like I mentioned. So if I wanted to draw a face card, you can just see out of all the cards in the deck, the face cards are over here, and there's a spade. There's jack, king, queen of spade, jack, queen, king of hearts, and jack, queen, queen of diamonds, and jack, queen, king of clubs. So let's just list that out. It's J of spades, queen of spades, king of spades. Then there is jack of hearts, queen of hearts, queen of king of hearts. Okay, and then jack of diamonds, queen of diamonds, king of diamonds. Then jack of clubs, queen of clubs, and king of clubs. And there you go. That is all of the event in draw a face card. The things that could, so those are all, of the things that you could draw to make you happy to get what you want to get a face card. All right, let me just make sure. Oh, and that finishes off this section 16.1. So please let me know if you have any questions. Don't hesitate to email me. All right, have a great day. Bye.